Hi, welcome to this virtual surveyor tutorial video where I will demonstrate to you how you can create an accurate triangular model of a quarry. This terrain has been created earlier on with the outputs from my photogrammetry process. I can navigate around very easily in Virtual Surveyor. But it is a tremendous amount of data, and I have some problems handling that in the CAD software I normally use. So, I would like to convert this terrain to a TIN, a triangular model that doesn't contain too many triangles, but just enough to model this terrain accurately. Virtual Surveyor contains the workflows to handle that process very efficiently. Okay, let's start. The first operation I'm going to do is to create a point grid in this boundary. I select the boundary and set the spacing here to 10 meters. Then I click Point Grid. OK. I can at this point already create a triangulation from this point grid. I make sure to select the boundary, and I triangulate. You'll see that you get a triangular model of this quarry. But when I look a bit closer, you'll also see there is not a good correspondence at every location. The triangles here don't align well with the vertical faces. So, I delete the triangulation and need to refine this survey. I need to draw break lines along these vertical faces. I select bottom bank break lines. Here, I enable the polyline drawing mode and set the color to red. In Virtual Surveyor, there's this great tool called the guided breakline drawing, which will assist me in this drawing process. So I enable that feature and will start drawing my breakline. The first segment here, and then the software will complete that breakline for me. At this point it stops, but I can continue here. And the software will finish the job for me. I also want to do that for the top bank. I'm going to change the color from red to yellow. Also here, I'll draw a first segment, and the software will draw the breakline for me. I navigate to the end, right-click to complete. I continue this process for the entire quarry. That complete survey would look like this. I select the boundary and triangulate again within that boundary. All right. I zoom in and I can see that I get a much better correspondence now of the vertical faces with the triangular model. Of course, it's not necessarily always perfect. And at this location there's a big rock that I didn't include yet. So, I'm further going to improve this. For example, in this case, I might add some additional survey points. I select the survey points layer here, enable the point drawing mode, and I add some points here at the side of this big rock. And I do this for the entire area. And then I'm going to retriangulate within that boundary. And you'll see that the triangular model will be updated for this rock, for which I just added some more points. Okay, and I can continue to do this until I'm satisfied. And now I'm ready to work with this surface in my CAD software. And this is one of the great things of Virtual Surveyor, which you can't do with traditional surveying. You have a way of verifying your survey work. In the traditional way, you would work outside, measure some points, go to the office, convert them to break lines, and do a triangulation. And at that point, you'd have no way of validating that the triangulation you've always created corresponds well to the reality. With drone surveying and Virtual Surveyor, you can always revert to the original terrain. And through an iterative process, you can further and further improve the triangulated model until to a point where you're very satisfied about the product you've created and which you can deliver with confidence to your customer. I hope you enjoyed this tutorial and that it was useful. And as always, if you have any questions, don't hesitate to reach out to us on support.virtualsurveyor.com.